so you should be on page 12. Today we're going to talk about hypothesis tests for mean. So we're going to go through the basics, like what conditions are there, stuff like that, and then you guys will actually carry one out. So what are the 3 conditions for conducting a significance test for population mean? Random sample, as always. Second one? Approximately normal sampling distribution. This is the one that you guys normally mess up because you don't write the word sampling. Third one, 10% rule. So n is less than 0.1 big N. Do you always have to check that rule? Finite sample, sampling without replacement. How do you check that the sampling distribution is approximately normal?
It comes from normal population distribution.
So if the population is normal, then the sampling distribution is automatically normal.
No extreme skewness or outliers.
In what?
In the
Box plot of the
sample distribution.
sample. So sample does not show extreme skewness or outliers. And then the last option is the central limit theorem. So if your sample size is greater than 30, then the sampling distribution is automatically normal regardless of what the population looks like. Do you have to check all 3 of those? No, just one of them. It's preferred that the population is normal. If not, then use the central limit theorem. The very last resort should be drawing a box plot of the sample. I don't know why you all do this sometimes, but some of you draw a box plot every single time no matter what. Like, I don't even give you the data, and somehow you magically come up with a box plot. So just know, you don't always have to have a box plot. How are these different from confidence interval? They're not. They're exactly the same. So exactly the same conditions as for a confidence interval. Is that also true for proportion? Kind of. What's the second assumption for proportion? Large sample. Do you check it exactly the same way between a confidence interval and a hypothesis test? Right. Do you guys remember with a confidence interval you use p hat, whereas for a hypothesis test you use p? So proportion, there's a slight difference. Mean, exactly the same. Can you close the door so that we don't bother her, please? Okay. What is the test statistic? You guys should be able to figure this one out. Z or T? T. Well, there's one of each. You remember how for confidence interval there were 2 formulas? One that involved Z, one that involved T? Okay. So this is going to be a Z score. What do you think goes in the numerator? Oh, man. Whew. Okay, let me help you out a little bit. Here we go. Test statistic. Statistic, subtract parameter over standard deviation. What is our statistic in this case? X bar. So X bar minus, what is our parameter? Mu. They both stay like that, X bar minus mu. So whether you use Z or T, same exact numerator. Standard deviation of the statistic.
The sigma over the root.
Sigma over root n. So here we're going to have sigma over root n. What about for T? It's not going to be exactly the same. That wouldn't make sense. S over root n. Okay, we talked about this before. Which one of these do you think that you're going to use most often? T. Bless you. I don't know that I've ever seen an example where Z is used. It's very unrealistic to know the population standard deviation. So most of the time you're using T. Okay, what is the T distribution? We've kind of talked about this already. What is the shape of a T distribution? It can't be the same as normal, right? Because then why are there 2 different distributions? Bell-shaped. Yeah, so it's symmetric. Bell-shaped. And then here's the difference between T versus normal. A T curve has heavier tails. That being said, the t-curve approaches a normal curve as the degrees of freedom increase. So as you go to infinitely many degrees of freedom, your t-curve becomes the z-curve. Center of a t-distribution?
The
Sigma? Sigma is standard deviation. No. Okay, so let's think real quick. When you guys use normal CDF on the calculator, you have to put in a lower bound and an upper bound. What are the other two pieces of information you have to give the calculator? Standard deviation and mean. So that tells us in a normal distribution, the standard deviation changes, the mean changes. When you found a probability using t on the calculator, you put in lower bound, upper bound, what else? Degrees of freedom. That's it. So that means every single t-distribution has the same center, since you don't need to tell the calculator what the center is. Center is 0. Every t-distribution is centered at 0. Spread. How does the spread of a t-curve compare to a normal curve? Yeah. So a t-curve is more spread out than the z-curve. What does z mean? Like, what's the term for that?
normal.
Something normal. Standard normal. Z is standard normal. Okay. How do you calculate p-values using the t-distribution? Two options. You can use a calculator or you can use a table. So I'm going to do this first example with you, and then you're going to do the second one. We're going to calculate the test statistic and p-value for the following settings. So we're testing the null that the mean is equal to 10 versus less than 10. We took a sample size of 35, got a sample mean of 9.7 and a standard deviation of 2.1. Sample standard deviation, so you're going to use t. So we get t equals x bar, so 9.7 subtract 10, all over the standard deviation, 2.1 divided by the square root of 35. If you trust me, I will tell you that's about negative 0.845. Okay, so we are calculating the probability that t is less than or equal to negative 0.845. What else do I need to do or say before I can calculate this probability? Degrees of freedom. Sample size of 35, we need 34 degrees of freedom. So I will show you the table. This is personally my least favorite way to calculate this probability. So I don't really like this, but I will show you anyway. Okay, so here's the way this table works. The table only finds an upper probability. The probability we are looking for is down here. So we can find the upper probability instead, and then they're going to be the same because the distribution is symmetric. Follow so far? Okay, so then what you're going to do, instead of looking for negative 0.845, you're going to look for positive 0.845. There's no 34 degrees of freedom, but there's 30. So you're going to look and find where your test statistic falls. So you guys see that it falls between these two values? I don't know if you can see it. This one's 0.683, this one's 0.854. So our test statistic falls in between those two. If you go all the way up to the top, this is the probabilities. So the p-value is somewhere between 0.2 and 0.25. You follow me? Okay, so then you would say something like p is between 0.25 and 0.2. So you can probably see already why I don't like doing that. I personally want an exact p-value or a better p-value than that. So other option on the calculator. You're going to go to second distribution, t-CDF. You have to put in lower bound, upper bound degrees of freedom. So lower bound is negative 1 times 10 to the 99th. Upper bound is negative 0.845. And then we have 34 degrees of freedom. So we get a p-value of 0.202. this probability is about 0.202. In this case, would I reject or fail to reject the null? Fail to reject. Greater than 0.05, you're going to fail to reject. Questions?
If something says it's statistically significant, does that mean it's failed to reject?
No, means you reject the null. Okay, I would like you guys to take 2 minutes and do part B with the person next to you. I want you to calculate the test statistic, calculate the p-value using both the table and a calculator. So you should get a similar p-value either way, but I want you to be able to do both.
Thank you.
Yeah, and then you multiply by 2.0.
What did you get? How do you, is it TC or TP? I'm doing it. It's just source.
What's up?
What? I don't know how to do it. Start again.
So if it's like negative, you would do
Just Bowden, what is the order for the TCDF?
Lower bound?
Hold down and then triggers of freedom.
Yep. Okay, let's see how you guys did. Hey, are we ready to come back together? You should have done 93 subtract 85 over 10.3 divided by the square root of 16. which is about 3.107. So then you are going to find the probability that t is greater than or equal to 3.107 and multiply it by 2, which I think is 0.007, with 15 degrees of freedom. Sam?
Since it's like 2 seconds,
Yep.
how do you know to do like the probability that t is greater than 3.17 and not less than?
Okay, so what you do is if you think of your figure, center is always 0. You got a test statistic up here. You are always calculating further away from the center.
Okay.
So in this case, further away is that way.
Okay.
Okay. Questions on calculating a test statistic or a p-value? What do you guys prefer, the table or the calculator? Yeah, me too. Okay. There is a way to do this on the calculator, but of course I'm not going to show you yet. Are you guys ready to do an example? Yeah. Wonderful. Example on the next page. Okay. Do you all feel that we need to go through this together? Yep. I think it's better if you all try rather than us going through it together. You know how to calculate a test statistic, you know what conditions to check, you know how to calculate a p-value. So, it's pretty similar to proportion except you're obviously using mean instead of proportion. So let's go for like 15 minutes. Try to go until 2:05, do both parts A and B, please.